Hi everyone, my name is Michael Bowyer. Today I'll be presenting with my partner Paul Babala for the ECE 574 final project demonstration for the fall 2022 semester. We'll be presenting a personalized security system which we developed using the software development lifecycle method known as extreme programming. Here's the agenda for today. We'll first introduce the project along with why we selected extreme programming for development. We'll go through what the project's requirements are as well as its design. We'll then demonstrate the project, go through how extreme programming was used during its development, and finally provide some thoughts on what we learned using extreme programming in the development of the system. So from the outset of the project, we decided to go with extreme programming. The reason for this is because we lacked experience with it, but had experience with other agile methods. And we also wanted to find a method which focused on the delivery of the product. We realized that we would have to simulate a change in requirements during the project. So this is actually simulated in two requirement phases, which Paul will explain in the next slide. So we then decided a good system to simulate that change would be a personalized security system. This system would have two components, a Raspberry Pi acting as a security system and an Android app, which is the user interface. We thought this was desirable because it had inclusion of hardware as well as the Android app, and we know that app development is known for fluctuating requirements from users, especially appropriate for XP. And finally, the novelty within the system itself is the customization of the audio playback during the alarm being sounded.
For our Phase 1 requirements, we focused on the following. A system scheduler that would control the status of our LED lights. An Android app would be used to control the times the LED lights were on or off. The system would be armed by the user. Currently, the system does not display a light when armed. The system will be alarmed upon a sensor's trigger. This would occur when the door or window sensor is breached. The system will alert when motion is detected. The motion sensor is capable of sending an audio signal, but cannot send a notification at this point. For Phase 2, we modified and added additional requirements as shown by row 3 and below. The system can be configured to run different audio clips via the Android app when the alarm was triggered. The system will have its LEDs configurable via an Android app, and the system will turn on the LEDs when motion is detected. Follows is the system architecture. The Raspberry Pi was used as the data repository, peripheral driver, and sensor handler. The Android phone would connect via IP to change settings within the Pi. The option for Bluetooth was dropped because of a lack of need due to the IP link being necessary for alerts. The diagram to the top left details the first level of design. The monitor program interacts with the user to provide setting changes to the data repository. These updates are then sent back to the user as feedback, as well as to make changes to the peripherals. The diagram to the bottom right details the second level of design. The sensors will create events to notify the monitor program. These events will be filtered by the monitor program to create a most up-to-date version of the data repository, while shielding it from invalid sensor trips. This repository is then given to the Android app as well as external output peripherals.
We also documented a sequence diagram to better provide information regarding where information is flowing and when it flows from which system to which system. So we have obviously a setup where we expect the Raspberry Pi to be up and running. We have the Android app, which has been installed on an Android device. And once initialization occurs, the Android app establishes a connection with the Raspberry Pi. The Raspberry Pi then sends all of the information for all of the state and settings information stored on it to the Android app. The Android app then displays it to the user. And we kind of reuse this information for any change in system state or setting. So when the Android app, for example, is changed, where the user changes, for example, the alarm state, right? The Android app internally stores that information, transmits it to the Raspberry Pi. Raspberry Pi effectively makes that change, stores it internally, and then retransmit that this is the current state to the Android app. And finally, the Android app sends that information to the user. One really good example of how we use Extreme Programming to keep things simple was to essentially reuse the single packet structure to send data back and forth between the app and the Raspberry Pi. We designed one packet structure, which as you can see here, which enables particular information using a control byte. And really, the reuse of this single packet allowed us to prevent redesign or excess design for transmitting and receiving from each individual system. Now we have one packet which can be used bidirectionally.
This is our demonstration for the project, the main components being an Android phone. This is an output device going through a 3.5 millimeter jack, a Raspberry Pi, which is also connected to an LED light source, a window and door sensor. The way these work are if they are not in contact, just this little white piece, it'll trip the alarm, and then a motion sensor, which is hidden underneath this box. It can be a little touchy. So if I start the app up, it'll start with the main screen. So what I'm going to do right now is go to the settings and change when the automatic light sequence can be on. The system will work just by having lights set manually by the phone itself. So if I go, I can now engage the lights on, and we see the red light here. So also here is an option to change the color of the lights. So I'm going to change it to instead be a blue color. And we can turn the lights on and off. If I go back to the settings, there's also an option to change the sound of the alarm. In this case, I'm going to pick the bottom one here and then go back and then engage the alarm. So the first thing I'll do is trip the door window sensor. So you can see you have a blue light for the door window sensor and then the primary kind of sound. This sensor won't reset unless you do it through the keyboard. And we'll let the audio go through to the next cycle. The next sensor is then the motion sensor. Like before, it won't trip until the box is removed. Once the box is put on, then the alarm is ready to rearm, which I'll then do the same thing. Press R and it'll reset. Thank you for your time.
So how was Extreme Programming used during the development? Well, there was many practices that we used from Extreme Programming. The first is pair programming collective ownership, where we had a single repository which was developed by both contributors, and we had virtual pair programming sessions for most of the code that was written. Next, we had small increments. So each of our small increments was really the next requirement that needed to be completed. This allowed us to have very concrete goals for the next increment. We had communication via code, and a really good example of this was our test server program, where we essentially shared the same code between both the Android app and the test server. And that way, when we were using the interface between the two, we just documented it using code to show how it was tested. We also had very simple design. Here we documented wherever necessary. So for example, the packet structure diagram when it was necessary. And we also developed the sequence diagram, which utilized the same packet structure bidirectionally as mentioned earlier. A good metaphor also was the guide from the simple and small requirements, which we mentioned earlier. And finally, refactoring. So we used quite a bit of refactoring. I think the biggest example was when the Android app we had initially developed just to show all the different user interface elements was essentially requiring an update based on when we needed to be updated because a message was received. Some other practices which we use, but not to the fullest extent expected from Extreme Programming, were planning game, where we of course always had the next increment, but we didn't actually weigh it with different business priorities, the timeline, or the different resources we had. We also didn't have an on-site customer. We tried to simulate it with the changing requirements midway through, but of course that had its limitations. And we also implemented coding standards on a very small scale, never really formally documented because it was just between the two of us, but they were at least in place. You know, they Unused practices, which we couldn't actually get to, were in continuous integration and just testing. So there was pretty high complexity when testing user interface stuff for the Android app, and pretty hard regression testing for hardware stuff, because it required a continuous connection to the different hardware pieces. And obviously, continuous integration requires some automation, which we didn't invest in, but we learned it would have been very helpful. We also, of course, didn't implement the 40 hours a week concept because it just wasn't compatible with us being both working students. So final thoughts about the project. Of course, we wanted to actually gain experience using XP, although we did have some challenges simulating a realistic scenario, because of the changing customer requirements were simulated, not having a customer there. We had some difficulty developing for just phase one without letting phase two requirements influence our mind. We had very well crafted requirements. Usually that's not the case. And we also had some inability to put into place all practices expected by XP due to just the resources we had available to us. However, despite all of that, we did gain a lot of knowledge for XP. We realized how effective it is when resources are limited and really you can focus directly on the product. The small increments were really vital to being able to do things well. We really wish we would have invested in continuous testing integration. It definitely would have been a worthy investment. And finally, we realized that refactoring became much more difficult with more increments. So yeah, that was our learnings from the project in the semester. Yeah, thank you for listening. Take care. Bye.